All right, I'm going to start looking at comparing relationships with equations, and kind of now this is what do equations of proportional relationships look like. All right, so notice and wonder patterns with rectangles. So looking at this, you can kind of see a pattern. Well, it looks like everything doubles, so side lengths double. Also, the number of square units that make up each one. So there's 3 squares, there's 3 times 4, so there's 12 squares now. There's 3 times, now it would be 9. You get the total number of squares, 27 here. So the area is also changing, but as far as, or patterns, those are the two that we see. So side lengths increase by the same. Same factor, I should say. And area changes by the scale factor squared. So that's the two patterns that are noticed here. All right, there might be another one that you might notice, but it should kind of fit along with those lines. Okay. 8.2, more conversions. So it says the other day you worked with converting meters, centimeters, and millimeters. Here are some more units, more unit conversions. So you use the equation F equals 9/5 times C plus 32, where F it represents Fahrenheit degrees, C is Celsius degrees. So we'll go ahead and complete the table. The table is up here. So once again, that equation is F So F equals 9/5 times C plus 32. Okay, so the first one, so if C is 20, so 20 divided by 5 is 4. 4 times 9 is 36. 36 plus 32 is going to give us 68 degrees Fahrenheit. Okay, next one, if it's 4, so 9/5 times 4 plus 32. That's going to give us 36/5, which is the same as 7 1/5 plus 32. That's going to equal 32 plus 7 is going to give us 39 degrees, and then the 1/5. And 1/5 is going to equal 0.2, so this is 39.2 degrees Fahrenheit. Then the last one, 9/5 times 175 plus 32. So 5, that would be 20, 30, 35. 35 times 9. So I took 175 divided by 5, so the 5 on the fraction part. That gave me 35. 35 times 9 plus 32. 35 times 9 is going to give us 9 times 5 is 45, carry the 4, 27, so that would be 315, plus 32 is going to give us 347 degrees Fahrenheit. Okay, so we filled this out. So now to see if it's proportional, you can do 68 divided by 20. and that's going to give us 2 and 8, nope, sorry, not 2, 3 and 8/20ths, which can be reduced to 2/5. 39.2 divided by 4. Well, that I know 4 can go into 39. 9 times, which would be 36. So right there, and then you have some left over, but right there that just shows us that these are not equal, so that table is not proportional. Okay, the next one, it says use the equation C equals 2.54 times n, where C represents the length in centimeters, n represents the length in inches, to complete the table. So the first one, 10 times 2.54, that's going to equal 25.4 centimeters. 8 times 2.54, that's going to equal 20.32. And then 3 1/2 times 2.54, that's going to give us 8.89. Okay, now if we take 25.4 divided by 10, we get 2.54. If we take 20.32 divided by 8, we get 2.54. And if we take 8.89 divided by 3.5, we get 2.54. So we have our constant of proportionality. And if you notice, that's what we are multiplying our n by in the equation. There's nothing that we're adding on to it. So therefore, this is a proportional equation. Where this one, our equation, we have the constant, but then we have this addition of 32, which that's going to tell us that that no longer is a proportional relationship. Okay, so are these proportional relationships? Explain why or why not. We just went over that. When you divide your y by your x, or in this case your c by your n, and up here your f by your c. On the first one here, we don't get the same value. On the second one with centimeters, we do. So second one's proportional, first one is not. All right. So now looking at some more equations from what we have here, we have 3 tables to fill out, and it's all based on these squares, or these cubes. So the first one is, how long is the total length of each cube? Well, there is 12 lines on each one here. So if each line is 3, it's just 3 times 12. Well, 3 times 12 is going to equal 36. 5 times 12 is going to be 60. 9 1/2 times 12 is going to be 114. 12 times 9 is 108. And then half of 12 is 6, so 108 plus 6 is going to be 114. And then so here all it's going to be is 12s. Okay, so that's going to be our equation. So you could just say S equals, nope, not S, sorry, the length equals 12 times S. Okay, this next one, so now what is the surface area of the cube? So there are 6 sides to a cube. Each one is going to have the same surface area. It's going to be your length times width. So area equals length times width times 6. Okay, our area of a square, 6 times. So 3 times 3 is 9. 9 times 6 is going to give us 54. 5 times 5 is 25. 25 6 times is going to be 150. 9 1/2 times 9 1/2, that's going to give us let's see, 9.5. No, that's 5. That's going to be 90.05. Oops, and then that times 6. And when you multiply that by 6, you're going to get 541 and 1/2. So then, to find our surface area, it's going to be our length squared times 6. So whatever S is, it's going to be 6 times S squared. So our equation here would be area equals 6S squared. Okay, last one, it says the volume of a square is base times width times height. So V equals base times width times height. And with a cube, once again, all those are the same value. So 3 times 3 times 3 is going to give us 27. 5 times 5 times 5 is going to give us 125. 9.5 times 9.5 times 9.5 is going to give us 857 and 3/8. And then so our answer here would just be S cubed, S to the 3rd power. S times itself 3 times. Okay. Which of these relationships is proportional? Explain how you know. Well, if we take 54 divided by 3, you're going to get 18. Oops, sorry, I should start on the first one. Okay, 36 divided by 3 is 12. 60 divided by 5 is 12. 9.5 divided, or 114 divided by 9.5 is 12. And so what we see here is there is a constant of proportionality. There's a number that we get every time we divide our y by our x, and it's the same number. So this first one is proportional. Second one, 54 divided by 3, that's going to give us 18. 150 divided by 5, that's going to give us 30. Okay, so right there we can see these are not proportional. We've already got 2 different values when we divide our y by our x. Okay, last one, 27 divided by 3 is 9. 125 divided by 5, that equals 20, nope, that equals, 25. And once again, you see these are not the same, so they cannot be proportional. Okay, it says write an equation for the total edge length, E. So E is going to equal 12 times, I'm just going to use L for length. Right, that would be for our first table up here. Okay, that's how we're getting our answer. For the second one, area is equal to 6S squared. So once again, this comes from what we're getting here when we have S as a length for our cube. And then the last one, we're just going to use this value right here. So volume equals S cubed. Right, so note, this one right here was proportional, the other two were not. This one is just a number times your x value. In this case, x is replaced with L. Down here, our x value is actually squared. X is just replaced with S. And then on the same one, on the last one, that's S to the 3rd power. So that'd be like x to the 3rd power. So note that when we're looking at if a equation is proportional, because an equation that is proportional follows this formula, y equals k times x, where k is your constant of proportionality, and x is your input, y is your output. Okay. So we're going to skip the are you ready for more. If you'd like to look over those and see if you can figure them out, that's great. But to save time, I'm going to hit this last one, 8.4. So it says all kinds of equations. So here are 6 different equations. Predict which one of these represents a proportional relationship. Well, this one right here follows the formula. The y equals k times x, where k is your 4. This one also does. K is just going to be 1/4. So y equals 1/4 x. Because when you divide by 4, it's the same as multiplying by 1/4. This one here, oops, sorry, I should have. Looks like it could be, but you're dividing by x instead of multiplying x by a number. So this one should not make a proportional relationship. This one as well has an additional number we're adding to x. And then these two are raised to the powers. One is the power is x, the other one is x to the 4th power. So those ones should not be. So only the 2 that I drew rectangles around should be proportional relationships. So now we're going to complete the tables and see if that's true. Okay, so for the equations, 4 plus x, so 2 plus 4 is going to be 6. 6 divided by 2 is 3. 3 plus 4 is 7. 7/3 is what you get when you divide. 4 plus 4 is 8. 8 divided by 4 is 2. And then 5 plus 4 is 9. 9 divided by 5 is 9/5. So note that our y divided by our x is not the same. All right, where y equals 4 times x, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, and 5 times 4 is 20. 8 divided by 2 is 4, 12 divided by 3 is 4, 16 divided by 4 is 4, and 20 divided by 5 is 4. So that one checks out. Our y divided by our x always stays the same. And once again, note the form. It is at y equals k times x, where k is our constant of proportionality. Okay, next one, 4 divided by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. 4 divided by 3 is going to be 4/3. 4/3 divided by 3, which is the same as multiplying by 1/3, is going to be 4/9, which you can see is not going to be the same. 4 divided by 4 is 1. 1 divided by 4 is 1/4. And then 4 divided by 5 is going to be just 4/5, which is going to give us 4/25 when we divide. So those are not the same. It's not proportional. Right, x divided by 4, so 2 divided by 4 is going to be 0.5. 0.5 divided by 2 is going to give us 0.25. 3 divided by 4 is going to be 0.75. 0.75 divided by 3 is going to give us 0.25. 4 divided by 4 is going to be 1. 1 divided by 4 is going to be 0.25. 5 divided by 4 is going to give us 1.25. 1.25 divided by 5 is going to be 0.25. So that one checks out. Our y divided by our x is always the same. Okay, y equals 4 to the x power, so 4 squared is going to be 16. 16 divided by 2 is 8. 4 cubed, or 4 to the 3rd power, is going to equal 64. 64 divided by 3 is going to give us 21 1/3. Okay, and then 4 to the 4th power is going to give us 256. 256 divided by 4 is going to give us 64. And then 4 to the 5th power is going to give us 1024. 1024 divided by 5 is going to give us 204 and 4/5. Okay, once again, our y divided by our x is not the same, so it's not proportional. Last one, the number to the 4th power, so 2 to the 4th power is going to give us 16. 16 divided by 2 is 8. 3 to the 4th power, so that's 3 times 3 times 3 times 3 is going to give us 81. Oops. 81. 81 divided by 3 is going to give us, let's see, it's going to give us 27. 4 to the 4th power is going to give us 256. 256 divided by 4 is going to give us 64. And then 5 to the 4th power is going to give us 625. 625 divided by 5 is going to give us 125. Once again, our values are not the same. Our y divided by x is not the same. So this is not proportional. So as shown, these were the two that were proportional. The ones predicted in the first one. And they follow that pattern of the y equals k times x. Okay, where k is 4 in the first one, and then k equals 1/4 in the second one. So do these results change your answer to the first question? Explain the reason. If looking at those equations you thought differently, now this should hopefully explain why those were the only two that were proportional. The last says, what do the equations of the proportional relationship have in common? Well, once again, they follow that y equals kx, where x is not to a power. We're not dividing by x, or we're not adding anything to x. So it's this form where there's just a multiplier that we multiply x by. All right, so that's looking at equations and kind of how you can verify just by looking at an equation if it is proportional. So once again, it's going to follow this format.